All right, here we are, day 24. Yesterday, I ran into a bunch of issues. The using an immutable list. I mean, I did end up looking for help and seeing an alternate way to solve this with just a simple array. Basically, doing way too many operations. There's a few tricks there that could be done to where you're only modifying 3 values at a time. So that's a huge reduction of what we were doing previously, where we're, creating a whole new list every time we do an insert, moving things around all over the place. We didn't really need to do inserts. We could have just gotten by fine by modifying values 3 at a time. The thing is that like once you like kind of started going with that, you didn't really need to worry too much about the entire list as a whole. There's a few tricks around making it in a proper state without, reconfiguring the list or rebuilding the list. So yeah, that one was a huge pain. I got got 8 hours because I, gave up the night before and then took a crack at it in the morning. That's probably a programming pro tip right there. Get 8 hours of sleep. It makes a huge difference when solving these head scratchers. And normally I don't really go nonstop when I'm working on something. I usually take, breaks, go for a walk, kind of think about what I'm working on, then come back at it. Or do what some people call rubber duck debugging. Can certainly help quite a bit. Let's see, day 24. Your raft makes it to the tropical island. As you enter the lobby, you discover a small problem. Floor is being renovated. They finish installing the new tile floor. Until they finish the new tile floor. Tiles are all hexagonal. They need to be arranged in a hex grid with a very specific color pattern. Not in the mood to wait, you offer to help figure out the pattern. The tiles are all white on one side and black on the other. Tiles are all white on one side and black on the other. Okay, like Othello. They start with the white side facing up. The lobby is large enough to fit whatever pattern might need to appear there. A member of the renovation crew gives you a list of tiles that need to be flipped over, your puzzle input. Each line in the list identifies a single tile that needs to be flipped by giving a series of steps starting from the reference tile. The center of the room, okay? Each line starts from the same reference tile. Okay, because the tiles are hexagonal, every tile has 6 neighbors, east, southeast, and so on. These directions are given in your list respectively as E, S, E, S, W, so on. Tile is identified by a series of these directions with no delimiters. For example, East, ES, E, and EE identifies the tile you need to land on. If you start in the reference tile and then move one tile east, one tile southwest, one tile northwest, and one tile east. Okay, in the above example, 10 tiles are flipped over to black and 5 more flipped twice to black, then black to white. What are we starting out with? All the tires are all white on one side and black on the other. They start with the white side facing up, okay? In the above example, 10 tiles are flipped over. 5 more are flipped twice. After all of these instructions have been followed, a total of 10 tiles are black. Go through the renovation crew's list and determine which tiles they need to flip. After all the instructions have been followed, how many tiles are left with the black side up? Interesting. So how do we represent a hexagonal array? I guess it could be like a massive 6D array. Like 1, 2, 3, 4, 5. A 6D array. Let's see. How big is the floor space? Let's see. Total of 10 tiles are black. I guess we only need to count how many ones we've changed. I guess this could technically be a Boolean. Let's start with creating our paths. So we're going to have something weird like this. And we need to make it so that Can we do this with regex? What are our directions? Let's see. Input is line. Pattern is regex always gives me issues when I want to iterate through it. Now, what do we want rules to be? I guess just a string array would be fine. Matches I value. And then we'll have list of lists for rules. List of string rules. All right, let's see what that looks like. Let's see, so our rules, we have 20. Our first rule, southeast, southeast, northwest, northeast, northeast. Is that correct? Yeah, it's actually pretty interesting that that worked that way. All right, and then oh boy. How about a dictionary of tuples? 3, 4, 5, 6. Oh my gosh, that looks terrible. And for each rule and rules, let's see. Let's create our tile. Oh, it should just be a bunch of zeros. 1, 2, 3, 4, 5, 6. And let's have a function here. Move tile. Oh my gosh, this is so ugly. Tile and string direction. Let me Google this real quick. Let's see. Diagonal coordinate system. Oh, look at this math. Let's see. Wikipedia says that this can be a three-dimension array. Zero array. 0, 0, 0, 0, 0, 1, 0, 0, 2. I'm looking at this. Let's see, so if we started at here, we wanted to go east, that would be adding 1. There's no south, but if we wanted to go southeast, that would be adding 1 to here. Okay, so let's scale back this insanity to a 3-dimensional array, as Wikipedia is telling us. See, it certainly helps with these kind of things if you actually have an idea of how to move around. So let's see. Let's create a switch on direction. So case south. Let's see, that'd be tile item 1. We add. Is that correct? No, we don't have a south. What are my dumb directions? Okay, let's start with the east. East is item 3 plus 1. All right. And what's next? Southeast. So south into the east, that'd be plus 1 to item 1. Next one is southwest. So that'd be this guy moving down here. So this is 001, and we'd be moving to 100. So -1 to item 3. And +1 to item 1. All right, next. After southeast, we have west. That's just -1 to item 3. All right. After west, we have northwest, which is up and to the left. So this is 100. We'd be going to 000. So -1 on item 1. All right, and lastly, we have northeast, which would be here and up and to the right. So that would be -1 on item 1. I messed something up here. Northwest, it would be up and to the left. Oh, northeast is up and to the right, so this would be -1 to item 1 and then +1 to item 3. All right, there's our movements. So here we say reach var direction in rule tile equals move tile and direction. And then at the end of this, if tiles that contains key, if it already contains our tile, then we're just going to, this needs to be shorter. All right, if it already contains our tile, we just need to toggle it. So tiles, tile does not equal. No, wait, that doesn't work. All right, so if it was false, now we just need to do this. All right. Otherwise, we need to add it to our list. Tiles.add tile and true, meaning it's black. And then down here, tiles.count where the tile is true. Value. ToString. All right, what do we get? We get 9. And the correct answer is 10. Oh, it probably helped to get rid of whatever this is. Here we go. All right. So let's get our test input. Run this, get our value. All right, part 1 down. Part 2, the tile on the floor of the lobby is meant to be a living art exhibit. Okay. Every day the tiles are flipped according to the following rules. Any black tile with 0 or more than 2 black tiles immediately adjacent to it is flipped to white. Any white tile with exactly 2 black tiles immediately adjacent to it is flipped to black. Here, tiles immediately adjacent means the 6 tiles directly touching the tile in question. The rules are applied simultaneously to every tile. In the above example, the number of black tiles that are facing up after the given number of days has passed is as follows. All right, let's get back to our test input. Let's see, how are we going to apply these settings? Any black tile with 0 or more than 2 black tiles immediately adjacent to it are flipped to white. So we're not creating a full grid. So we can solve this one first. So our first step is going to be to do this. To create our initial tiles are all flipped according to the following rules. I assume they mean we need to apply our rules first. And then we apply these rules. Any black tile with 0 or more than 2 black tiles immediately adjacent to it is flipped to white. All right, so this is our days, right? So we want to go to 100 days. And for each one, let's see. So we probably want to figure out something. Maybe this to get our neighbors first. So our neighbors is going to be what? Why don't we ever modify tile 2? It's weird that we still got an answer, but that's fine, I guess. So our movement is not exactly correct. So we need to account for movement between the 0 array and the 1 array. So if we're moving south, not only do we edit tile 1 or item 1, we also need to edit item 2 . But how would we know we're in the 1 array or the 0 array? Hmm. Oh, it kind of explains it right here. So let's update this to move properly. Let's see, east, item 3 plus 1, that's correct. East and west is good. Southeast is... Wait, what? What is R? Oh. I'm just going to blindly copy this and see if it works out. I'm going off this weird HECS pixel. High hexagonal and efficient coordinate system. Let's see. Convert to Cartesian. Does this make sense? So let's see, if we were in 0, 0, 0, and we wanted to move southeast, that should take us to 1, 0, 0. So 1 minus 0, item 2 plus item 1, which is 1. I guess maybe we should make this change before we modify item 1. All right, southwest. Again, we do this 1 minus item 1. Item 2 is the same, but 3 is different. 3 is item 3 minus 1 minus file dot item 1. Okay, and west, yeah, that's good. Northwest, it's this again for item 1, which is weird, but whatever. Item 2, 1 minus file dot item 1. And item 3 is plus equal tile dot item 1. right, we're almost there. All right. Northwest. We do this again for item 1. Item 2. Yep. And then item 3 is similar. Right. Oh, wait, we messed up. This is northwest. This is west. And west is just going back on tile item 3. Okay. Let's run this real quick, see if we still get 10. No. All right, southeast. I think I'm mixed up northwest and northeast. Northwest. Yeah, this is north. This is northeast. And this guy is northwest. Okay. All right, so getting neighbors. I think we can cheat here and say, where's our directions? No? How about like this? Okay. All right, our list is of neighbors first. Directions. Neighbors.add. Move tile. Okay. That should be our returning our neighbors. So let's see. We only want to care about we want we have the rule of change to white. Black tiles with 0 or more 0 or more than 2 black tiles immediately adjacent. 0 or more than 2. Let's see, so tiles where black tiles and for each black tile, we want to select just the ones where let's see, get neighbors. Our nays. And then our black tile count equals tiles where change to white if we're 0 or more than 2. Now this should be count. Okay, so that's our tiles that we need to change to white. Now the ones that we need to change to black are a little trickier. Any white tile with exactly 2 black tiles immediately adjacent to it is flipped to black. So we kind of need to do a reverse. We get all the black tiles, and then we get the neighbors that are white. And then on every one of those white tiles, we find out which one has exactly 2 black tiles adjacent to it. It seems to be a little heavy-handed. All right, we get our black tiles, and then we select many, I think. Okay. And from these, where It's white if we either don't know about it or if we do know about it and it's set to false, which is white. All right, so that's all our white tiles. And then we do another selection here. We do something like this. We can basically do the same thing, except contains B and the value is true. All right. Wait, you didn't like that for some reason. Oh, it's because we're scoping in. Oh, why aren't you complaining about this up here? Let's fix this just in case. Oh, this is... Yes. Yes. Okay. And then down here, we're going to update the tiles. So we should change this. We should call toList so these evaluate. Tiles. This one, no, I can't do this one like this. Okay. And then at the end here, we count the number of black tiles, which is this guy down here. All right, I'll be surprised if this works. 7, that is definitely not 2000. Let's see. I plus 1 and this. So we get 7 on day 1, which is, I mean, it's less than we start with for whatever reason. We should have went to 15. Any white tile with exactly 2 black tiles immediately adjacent to it is flipped to black. On the first one, we should be change to black is 0, change to white is 3. So what's wrong with our change to white? Or change to black, I mean. So let's see, we first get black tiles. And then we select many to get all the white neighbors. Where tiles.contains key or tiles key is set to false. So white tiles, this should be a whole ton. 47. Looks reasonable. And then here we say we get the neighbors of every white tile. And then we count tiles where it's one of the neighbors and it's set to true. Oh my gosh, what's step into F11? Okay, what's step over? Step out, shift F11. Right. First one we have 6 neighbors for tile, what is this? Tile 0, 1, -1. BT count is 0. Zero, 1, 0. Do we have a 0, 1, 0? No. Pretty much everyone is giving me 0. Hmm. Oh, what am I doing here? $15, $12. Okay. Alright, I haven't lost my mind. 9. It looks like I'm a step behind. Well, actually, no, I'm not, because I'm doing it up here. Alright, let's run this 100 times. We get... Ooh, it's slow. That's not what I want to see. I mean, the fact that I'm getting every single neighbor is probably not the wisest choice. $22.08, which is correct from what I remember. Where's my... Oh, I got rid of the advent of code. What am I doing? Yeah, 2208. Let's run this. It's pretty slow, but hopefully it'll finish eventually. Yeah, it's going to be pretty slow because of... Basically because of our white selection. Maybe what I could do is after this select many, to send it to a hash list so that I can get rid of duplicates. Let's pause this and see how far we are. What are we on? Step... Step 77? Okay. A little bit further. You can do it, program. Yeah, what is that like? Slower than factorial running time? not factorial, but slower than quadratic. No, wait, that doesn't make sense. It would be, yeah, it would be slower than quadratic. I don't know. That complicated, what is it called? Asymptotic notation. It's always been a little too difficult for me. Where are we at now? 95, almost there. Yeah, it's just going to get gradually slower and slower the further down we get. Oh. Ooh, 2-minute running time. 38:04. We got it though. Oh man, I would have thought that I would have gotten a better rank than this, but that's better than yesterday's. Oh, look at that time. Exactly 1 hour by the second. That's numerically pleasing. So yeah, let's see if just throwing that into a hash list makes it any, or a hash set makes it any faster. It doesn't look like it makes a huge difference. Or maybe we should set it down here? No, I guess it makes sense to be up here. Let's see, white tiles, how large are you? How do you see the count? Can you not look at the count? I don't know, what? Can I not inspect what the count looks like? It looks like it's running a bit faster, it seems. The fact that I'm pausing it probably doesn't help with the execution time, but yeah, this one was interesting. This is the first time I've worked with any hexagonal tiling. Yeah, it certainly helped to do a quick Google search and have Wikipedia show me what how to properly store hexagonal coordinates. I'm surprised this nonsense works. I don't even understand. I don't know what the running time was before, but it didn't really make a huge difference. Yeah, so that's pretty much it. I guess the only tricky part here was the fact that we were using the hexagonal coordinate system. Besides that, this is, yeah, pretty beginner level question, I guess you could say. Not beginner level, but a question we might have seen on the earlier stages if it wasn't for the fact that we had to think about this in hexagonal terms. I don't know. It was slow, but I kind of like this solution. I like being able to reason out with using lambda expressions and with LINQ, or lambda expressions in Python or Java's variant. Java is a bit more verbose when it comes to doing these. They have this streams, I guess they're called, which it's a huge pain to build, something like this in Java, at least for me. Yeah, that's day 24. Making our way through the lobby, I guess, to our tropical island. All right, that's it for this one.